Okay, people joining the live stream, this is a continuing series of meetings about geographical historical data. And let's see, let's just review what we concluded last time and then keep going. Actually, what do we think we have concluded this whole initial section here? I think we had invented, okay, let me just take a look here. Geographics of a time series, opacity needs to be weighted based on time span. Okay. Proposal for Geo within Q, we're okay. Duration should be expanded to take a second argument, saying what it's a duration of. Okay. I don't think that's just Shadi who needs to be contacted there. I think that's the time series team.
Okay.
Should only return conflicts that match the temporal span of the Roman Empire. Okay. You stated all. Okay. Output of a Geoidentify needs to be usable in timeline plot. Right. Okay. What does empirical distribution of a time series of polygons output?
So that's part of the unsolved discussion about if we should use this empirical distribution or something else like weighted data. So that's
okay.
What should be under consideration when they create this duration of a time series? What should that return?
Okay, hold on. There's another thing that sorry. The other thing we've been talking about, which doesn't seem to have made it on here, was the business about a new form of time series, event series, whatever. That is, what was that thing we talked about? The thing that is equivalent for from a hold from left time series, right? The thing that doesn't have the fence post problem about the beginning and end. You know what I'm talking about?
I think we were planning to somehow extend a bit time series to do that itself rather than introducing a new object. I think at some point, a couple of weeks ago, you talked about a dated object. Dated series.
Yes.
I don't think we need that.
Okay. And why is that? I mean, because a dated series would give a bunch of intervals, right? Would give the state of things over a bunch of intervals, right?
That would be the input, presumably.
Yeah, I understand. But are you saying that basically that time series could equally well take that series of data intervals and values?
Exactly. And internally interpret that it needs interpolation order 0 and then.
Okay, what happens if you? Okay, well, all right, fine. I'm fairly convinced about that. If indeed we think that it will always be the case, yeah, it's reasonable to just give the data interval for something. There are open and closed interval questions which you guys would have to deal with. I mean, Gosha, do you think this is reasonable?
Well, that if this is a partition of the date line, then we have no problems in a way of overlaps, right?
Well, what about machine precision and so on?
So that's again the case of closure, open, closed, right? Up to interpretation. So I think that date interval already has some, decision to be one side open, one side closed, so that resolves this issue.
Yeah, exactly. We're planning to have date interval by default to be closed on the left, open on the right, and then we can partition without overlapping the whole timeline.
I think we're going to need some kind of conformance function that takes a bunch of data intervals that don't conform properly and just knits them in some way. I see. Here's another case that I think is going to get awkward. So let's imagine that we have, what am I saying? We have polygons for historical countries, but they are granularized by year. Okay.
Yep.
And then, okay, look, what I suspect is going to happen, and maybe somebody can say with respect to the historical polygons, don't we have polygons where, at the Battle of Waterloo, the polygons changed, so to speak? Do we have polygons where on a particular day they changed, or are they only changing by year?
We only change them by year.
Okay. Do we believe that to be correct? I mean, as in, is there? Well, this is now in the category of I don't understand history well enough. But go ahead.
Yeah, we have some cases where we have when we know the end date, that's the ending date of the polygon for the.
And we know it to the day. Is that correct?
Yes, in some cases, not always, but yes, in some cases, yes.
And just out of this is a history question. I mean, a battle happens. See, I don't even know how this works. I mean, when there's a surrender treaty, one understands the moment when that treaty is signed, or the treaty says in it when certain things will become effective, right? But I don't know what one does. I mean, what does it even mean to say? My knowledge of wars is insufficient to. Do you understand the question I'm asking? Does it even mean anything to ask what the polygons look like? In other words, does it, unless there's a sort of legal-like process that happens, I don't know that we could ever possibly know these polygons. Anybody want to comment on this?
I think this is a matter of history, and we should assume that there will be different cases. Cases way in the past in which we just know an approximation, and cases in recent times in which we know the hour in which the treaty was signed.
If indeed it's happening by treaty, as opposed to, the army is retreating, and therefore, and it's completely unclear what that means for the border of the country.
I mean, there are certain defined border marks throughout history with primary documents, like Caesar saying, I took this town,
If one believes him.
Yeah. Right. Well, archaeology generally backs up the.
Fair enough. But I mean, so do we think, okay, but in that case, I mean, like, to the day, we wouldn't know back at that time, right? We don't even know what day of the week the Ides of March when Caesar was assassinated was, do we? I mean, so we obviously don't know. We couldn't even get that, even if we wanted to. We don't have enough calendar information going back that far to get it to the day. Is that a true statement?
Very rarely. Correct. That is correct, yes. Very rarely would we actually be able to pinpoint a day. And usually it's confirmed because there was some sort of eclipse that happened or something.
Right. But I don't even know, in the case of Brian on our live stream is pointing out that modern battles are well documented. Yes, indeed. Even ancient ones are surprisingly well documented, but one knows where the battle lines were, but that doesn't, whether we consider that to be the border of the country is quite unclear to me. Anybody want to comment on that? We may have the wrong set of people to discuss that.
I think my main point here is that we shouldn't forbid having very precise dates. We just have to do the best we can with the dates we have.
I understand that, but what I'm saying is, if you've got I see, you're saying that the date interval's endpoint could be a day.
Mm-hmm.
Yeah, here's the case that I knew there was a case I was thinking about, okay? The date interval's endpoint is a day. Oh, maybe this doesn't happen. I'm thinking the next date intervals is just a granular year, but maybe that wouldn't happen. I mean, in other words, I can imagine a case where we know something very particular, where we've got the data so that, and then my question is, what does it look like when there is a date interval which is a year preceded by a date interval which ends on a day? What does it do?
Well, my suggestion would be we assume that we are going to be covering the time axis, and we just mark the borders in the most precise date.
Yeah, fair enough. So in other words, if the value is, you know, if it's A for the thing that ends on January 31st, and it's B for the thing that covers the whole year, then until January 31st, it's A, and for the rest of the year, it's B. So effectively, the B start date is January 31st plus epsilon.
Right, and that will be a part of probably a function that will normalize these date intervals to make them continuous, single, or more.
Well, but okay, but that's why I'm saying, do we need a date conformance function that is exposed, which would turn that into that the B date interval actually starts January 31st plus epsilon, rather than the B date interval just is the granular year. Do you get what I'm saying? Yeah, I don't know whether we need it, but go ahead.
Yeah, that could be useful, at least internally, of course.
Well, internally for sure. I just don't know whether that needs to be exposed. Okay, fine.
Yeah, we talked briefly about having a conform dates function, sort of along the lines of, I think it's conform images, where you can have various calendars, various time zones, various granularities, and you may want to say, I want these all to be easily comparable dates, and we could have
It's a good idea. Let's do it, because I think the conform images thing is very much, conform images makes them the same size and so on.
Or compatible, so that the axes are or have the same number of rows or columns, but
yeah, I mean, conform dates. I like your point about different calendars and so on. Seems very relevant, and we could give a second argument to conform dates that is
like a specification.
Yeah, right. For example, a granularity specification. I mean, I could imagine that you would want to conform dates where, even though some of them you know to the day, you want to conform them all to be years. Anyway, okay, that's a separate thing. So let's keep going here to talking about the event identifier and these things, which I think is what we're talking about here, right? That was what we're talking about here, the temporal lookup function down here. Is that correct? Do I have a Dropbox location for this stuff?
It's in your historical data folder.
Thank you. Okay, so I'm sorry, the other unsolved problem was the estimated distribution business, right?
Right, but I wonder if that should be discussed by the duration team, so because that will be the output of this new function or the same function with extra arguments.
Well, I'm sorry, which one?
Duration?
No, I said, duration, yeah. Okay, but wait a minute. I'm talking about the thing where we're saying estimated distribution of the polygons in a time series.
You mean empirical distribution.
Sorry, empirical distribution, yes.
Yes, I mean, so...
I think Francisco's point is that it's just a matter of weights. So we might not need empirical distribution. Perhaps weighted data is enough.
Right, so it might be a simpler solution for that.
Okay.
But how would you get that out of the time series?
Well, so one thing that I talked to the image processing team and audio, and they have a function which is called audio intervals. And I think this is maybe something that could be used in time series, but I haven't,
So what does that mean? What is okay?
What it does do, it gives you the intervals for the certain condition on audio. And this is very specific to audio because it's about the audible and inaudible and such. But what it returns is actually an interval when this condition is satisfied, right? So this is what the weights that you would need are the durations of such intervals. So from this you can, for example, say that the audio was inaudible during this time, and so you could compute that.
Well, that's kind of weird. I mean, that's a date intervals
It's not really date. So in a way it's temporal intervals when you think about time series, because we not only have dates, we might have reals, ordered reals also as a timestamps.
Okay.
So in a way that's with time.
So
time
I mean, your
temporal.
proposal would be temporal intervals.
Something of that, yeah, of similar fashion.
That has a time series and has a criterion.
And a criterion that depends on the values.
Right.
Yes.
So that's a value crit.
Mm-hmm.
So what that really is, it's more like temporal positions. I mean, that would be another name for it. I mean, it's like position, right?
Yes. Well, yes, positions.
Okay, now notice this is about to be very similar to our event identify function. It's a very similar type of problem, right?
Yeah, not so sure, because somehow, that idea of date intervals is somehow the reverse of the thing we were talking about, converting the date intervals into a time series, which might be useful also under some other circumstances.
Okay, so wait a minute. There's another case, which is, okay, so wait a minute. There's time series of, okay, so here's an interesting issue. What happens if I just have a bunch of dates and I say, let's say table, let's say day range. I can do that, right? Now, how does that work?
You just give it a start date and end date, and it'll by default give you 1 day in between them.
Oh, what the hell is happening here? Oh, this stupid bug again. Okay, so now if I feed that into time series, what will it do? Well, what the heck did it just do?
Well, if you give just one input, it treats them as values and then automatically assigns the timestamps. So if you just give dates, it's gonna treat them as values and then assign.
So that's wrong, I think.
No, I mean, why? What would you like to be values for that case?
1 and 0.
Well, then it has to be the range that was created with the dominance that we have values and we would like to enumerate them. That was the.
I know, but if these things are dates, they are not meaningfully. You could distinguish a date from a plausible value.
I may also want to have dates as values.
No, I understand that, but if
so this is really the hard decision. You cannot just say this is too ambiguous to decide automatically. So the decision was made that if you just give one input, it's treated as values, and timestamps are.
It's unclear to me that that's right, but I mean, you were asking, how do we? Let's see. What am I trying to say? Somebody was saying, given a bunch of date intervals, yes, the reason we want a time series out of a bunch of date intervals is to be able to do things like determine whether you're on or off a date interval, so to speak. So, given a list of date intervals, is a given time in any of these intervals or not? See what I'm saying? Now, how would we determine that?
This is becoming close to interval member Q.
That's
right.
what I'm thinking, yeah. But now, I mean, if we gave a bunch of date intervals, so maybe that's just what should happen. Interval member Q should work on date intervals.
Yeah, I think my thinking right now is that interval member Q, interval intersection, and interval union should reasonably work with date interval. They don't have a meaningful operation with that head right now. And then the relationship for how do we deal with overlapping cases is when we look at things like date within Q and date overlaps Q. there's the question of I have an interval and then I ask whether this particular date falls inside it, and it falls partway inside it. The distinction between overlapping and within is helpful.
Yes, I understand. But date within Q should be able to take a list of date intervals as well, shouldn't it?
Yeah, I think it could. I mean,
No, why not? I mean, why not give that a list of date intervals?
Would you want then a list of Boolean values returned, or would you like a single value returned and to say, is this date a member of any of these intervals?
I think it's is this date a member of any of them, but how would you combine the date intervals into a single date?
But it already works over lists because it's effectively doing outer, like Geo within Q, which does the same.
All right, okay, fine. So it can't, okay, fine. But let me ask this question then. So how do I, that's similar to your time group concept, Jose, to combine that bunch of date intervals into a single blob.
Perhaps alternatives would be fine here.
It's a little weird. I don't think that's right, because I think you want something. I think you want a thing which is a disjoint times, you know, look, what you want is a, we don't have a date span, do we? Or date, rather than date interval, what would be this called? It's not a date object, it's a date, well, unless it is a date object. I mean, it's something like a date group.
So in the last time we discussed the date interval, we were wondering whether to have a multi-interval notation, like interval itself does. And then we could combine.
Yeah, then we could combine them just fine. Then all we would do is we would say date interval of the interval objects, int 1, int 2, and then we get a single, this is sounding like a better idea, that combines into a multi-interval.
Yeah, I think so. And it standardized the granularity between them if they were disparate, but we need to do that anyway.
Why would we have to standardize the granularity?
I mean, it basically, you know, we'd have to look at the smallest resolution for the granularities to be able to determine the appropriate endpoints. But if you gave a year, you know,
no. But what if it's these 3 days,
mm-hmm.
and then a bunch of years in the future? Then I don't think you want to more finely granularize the years. They're disjoint. It's okay to have them non-conforming.
Yeah, I was talking about so we talked 2 meetings ago about the interval itself can also potentially have a granularity.
Oh, okay, fine.
And
yeah,
so
I get that. Right, I understand.
But yeah, the individual points can have whatever granularity is appropriate.
Okay. Hey, let me ask another question. Whatever happened to the GeoPath with a time series, Geo time series, or whatever it is? You know, the voyages of Captain Cook, for example. You know, he went to Tahiti on this day, that type of thing.
I think you're referring to a concept of what we were calling geotrajectory, perhaps?
Yes, I am. And what's happened to geotrajectory?
That's being worked on for flight data.
Okay, so how does that relate to any of these other things? So geotrajectory, so we've got a time series of geopoints.
Mm-hmm.
What is the relationship between geotrajectory and a time series of geopoints?
Well, we can feed the time series of geopoints to geotrajectory.
Okay, so now let me be more awkward. What about a time series of geopolygons? Is that a geotrajectory?
No, I don't think so. So the idea of geotrajectory was that we would be able to get the velocity vector and acceleration, things like that, if needed.
Okay, let me ask the question again.
Mm-hmm.
I mean, somehow I'm reminded of string theory here, because it's like, you know, one thing is the world line, right, of a single point in space-time, and the other is a world sheet of some kind, or a generalized p-brane object, so to speak, if that makes sense. So the question is, can a geotrajectory sort of define why can't a geotrajectory define the space-time tube of a polygon?
Well, in these type of things typically have a very well-defined dimensionality, and that allows us to have properties, very specific properties, etc. So geopath. We are not mixing geopath and geopolygon. So why should?
Yeah, I understand. Okay, so geotrajectory has to be one-dimensional. So it's the geopoint with respect to time, you claim,
Right.
which would allow it. So what happens? What is the velocity then? So how do you take the derivative?
It would be something that we can query with another pair of brackets, and we can say velocity at this moment.
Okay, and what does that come back as? Some geobearing type thing?
GeoVector. It's a GeoVector that tells you at this position, at this time, it had this velocity.
And how does the GeoVector get units?
Units. Yes, it has units. GeoVectors can have any units.
Oh, is that right?
Yeah.
Oh, so GeoVector, yeah, that's right, because if it's a wind speed or something, it has a...
What you have on the right-hand side of the arrows, you can have any units.
I see, magnitude M and bearing alpha. So the magnitude M can have a speed.
Exactly. And alpha will be degrees. And we have the GeoVector E and U, so that all of them are speeds, etc.
I see. So okay, so what does it look like to get the derivative of a geotrajectory? You're saying that you would expect it to be just something like, okay, so hold on. So the geotrajectory, blah, 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 of velocity, for example.
Exactly, comma date.
Okay. Is there an analogous thing? So it's like an empirical... Wouldn't it be useful in the general... I mean, if you just have a bunch of points in space, for example.
Bunch of points. We need to know the dates, right? In order to be able to...
Yeah, so you have a time series. But my question is, how do you get the derivative of a time series? How do you get the rate of change? So we must have this. How do you get, given a time series, how do you find the rate of change of the value in the time series?
Gosia, can we differentiate the time series? Somehow?
Yeah, it's not a function formally. You could think about the path function as a function and then work with that, or you could just look at the in the form of approximation of differences, and have the quotients between the values and timestamps.
I think we should think about that. Yeah, go ahead.
Difference work already? Maybe that's the point, that difference should do something sensible with time series.
Difference, you said, or differences?
Differences, which is the function that takes a list and
you're right.
But it's not. Differences is for a list of discrete values, because time series has interpolation inside. It could be differentiated, like we can differentiate interpolated function.
So something to get the interpolated function of the
so I mean, with derivative of time series.
So if you do the path function from the time series, then it's an interpolating function, and then you can work with that.
Okay.
So apply derivative 1 to that to see if it works. Yep.
Well, let's give it times. I mean, I don't know whether that's a... Let's just take a look at that thing at the point 6.7. Very nice. Okay, so we could make derivative of time series work. Okay, but now geotrajectory then. Okay, but this tube concept we don't yet have, right? That's a time series of geopolygons. I mean, this is equivalent to, if I'm not mistaken, a time series of geopoints, of geopositions, right?
Yes, but it does worry about all the geo problems, curvature, etc.
I see.
It's three-dimensional, effectively. So
Okay, so it's similar to that, but not the same.
I would say it's some sort of extension. It knows more.
Fair enough. But so in the case of these tubes, we're imagining it's just going to be a time series of geopolygons.
Yes, but this is a lot more difficult because imagine that you have two different polygons in consecutive moments of time.
Yeah, I understand. The interpolation is non-trivial.
Exactly. How do you know which points of the boundary correspond to the other boundary?
By the way, with geotrajectory, we should get some nice things for the data repository, like the voyages of Captain Cook and so on. But so, just so I understand, in the case of those voyages, right? You know, he went to, well, I think he ended up in Tahiti and had a bad experience there. Let's see. Do you understand? I'm worrying about how you'd actually give that data. So let's see.
I would expect dates are all.
So this seems to be the actual thing, and presumably, I see. Presumably, they just took. In this particular case, they just have values that were the geo position at. You know, they did some star sighting or something every hour or something, and they knew where they were. Right, and then for us, then our geo trajectory, then we feed that into geotrajectory. Geotrajectory has an interpolation order, presumably. Does it?
I haven't thought about that yet, but it could. I think it could.
Fair enough. And then that would be how that works. Fine. Okay. Oh, Brian on our live stream is talking about general purpose mechanisms to discuss geopolygons associated with time series. Yeah, migrations, floods, etc. Yeah, I mean, the fact is, what we have on the Earth right now is geovector fields, right? That we have a notion. That's a true statement.
Geovectors, yes.
No, but what about the fields? Okay, let me ask you a simple question. The gridded population data for the Earth, how do we do that? Do we have a notion of a geodensity function?
Not yet, no. That's another concept we are working on. This has consequences for regions because it would be nice to have a concept.
I mean, it's basically a geo-interpolation function, isn't it?
Yes.
And then one could imagine a geovector interpolation function as well. Is that a true statement or is that silly? I mean, in other words, the wind, for example, would be a geovector interpolation function, if I'm not mistaken.
Yes, the geovector would be the data of the geointerpolation function.
I see, but we need some kind of special interpolation function for geo, don't we?
Yes, and probably the statistics team is working on something.
Okay, Gosha, can you say something about that?
Yes, but not in the immediate pipeline. But that's the interpolation. It's for the models of like fields models. And so imagine that you have 2 points at which you measure temperature and would like to know the values between.
Yeah, right.
Right, in
okay.
this kind of sense.
Let's go back to the temporal lookup business, okay? Just the, oh boy. Okay, all right. So the first question is the question of event identify or some such other thing.
Sorry, Stephen, your sound is a bit worse recently.
Oh, that's odd. Okay, that's very odd. Like today it's worse, or just right now it's worse?
Just a few moments. I think now it's a lot better.
Okay, fine. So I'm asking about this event identify thing. So the concept of, okay, so event identify, which I think is a horrible name,
Yeah,
No,
yeah,
I mean, go ahead.
we were wondering if this event identifier could really be, let's say, an implicit entity class with extended support for what you can do with the entity classes already. So if it will make more sense to actually expand entity class to this time manipulation instead of having event identify.
Well, the problem is that I think if we have event identify, we're going to need event within queue and all kinds of stuff like that.
But for example, this date within queue isn't that already that?
Say it again. What?
Date within queue isn't that already that? So
I see. So okay, so date within queue could be an entity and then a time.
Or
right?
another time entity. Right, maybe it's a matter of extending support for entities in date within queue.
Okay, so that will tell us, okay, so that tells us one thing. That tells us, okay, fine. But then we need to know GeoIdentify. So here's a possibility, okay, that we do something with GeoIdentify that involves dated. Maybe too crazy. Okay, so one possibility here is, let's say you want to say, well, you clearly should be able to say, and I think we already discussed this, what country was at this point at this time, right? So if I say GeoIdentify country, right? But if I then say GeoIdentify dated of country, 1066, that should return nothing. Well, it shouldn't return that. It should say didn't, missing or whatever else. Does that make sense?
Sure. Yeah. Sure. That's what we already discussed last time.
Okay, fine. Yeah. So
the question was for things that didn't have any geographical correlation, or when you wanted to do some kind of query that didn't involve any geo stuff. What would be the best way?
So that is basically, I mean, oh boy. So it's not a date identify, because it's not the, well, it is kind of a date identify. It is. It's like, go ahead.
I think they call that event because so you are not returning the date, you're returning a thing, an entity or something. That's
right. But the fact that we're calling these events, we're not officially calling them events. So what is the
But Francisco, is it true that these will have to return dated objects? So they will contain dates.
Well, will it return a dated object?
That's a good question. That's part of this discussion, of course.
Okay, so hold on. So then, okay, so we've also got GeoNearest. So we could imagine a date nearest as well, analogous to GeoNearest. And as we've talked about previously, we want...
Well, nearest works with dates already.
I understand that, but not with dates relative to the knowledge base.
Right. That's why we were wondering if we should improve the implicit entity classes to actually support these dated lookups. These date lookups better.
I think that would be nice, but I don't think that gets us off the hook for these other things.
I think we should look at that example there of the president of the US. So, for example, this event identify of the president of the US. I mean, it returns Donald Trump. Should it be Donald Trump at this time? Because those queries always involve a time, right?
Well, that's an incredibly weird input here. This government position boy, that's a really weird thing that we're returning there. Right? It's not just an event in this case. That's returning. So there are two things. This is a geo. Boy, this is weird. So one case of this event identify is, forget the Germany, it's just what military conflicts were there. Wait a second. So one possibility would be identify holiday. Okay? What holidays are going on right now? Does that make sense? So that's a pure time thing. That's okay. That goes to essentially worldwide holidays today. Is that right?
Right.
Whereas event identify holiday Belgium should give. So the second argument is kind of the GeoBounds of the event.
Shouldn't we maybe use restricted as it is already used in the interpreter? So to use restricted as wrapper of holiday?
Yeah, we could, I suppose. It's a little weird. Okay, so you're saying restricted holiday and then Belgium, for example.
Right. Which I think that's already a possible. Indeed, that's already documented in restricted, by the way.
Sure. But you see, this event identifier is really weird. I mean, maybe the general case is entity identify.
Yeah, and that's why I was also saying that maybe instead of creating this event identify, would be better to give all entity classes a better support for all this data stuff.
I think we need examples that are not geo-related at all, not related to countries, but still time dependent.
Well, like holidays.
Like
What's that?
Well, holidays are also related to countries, usually.
Yeah, okay. Eclipses are less related to countries. Okay, so what are some things that are, I mean, eclipses?
Full moon.
Yeah, right. Which we just wanted a function. We just added a function to compute the next full moon, right?
We discussed it, yes. I'm not sure we have started working on it.
Okay. But that's a similar thing. When is the next full moon?
Yep.
When is the full moon nearest to such and such a time? Humph. Okay. Okay, what is the general case of this? So the general case, as you say, you can do this with entity class. What will we have to extend to entity class? Extend with entity class? You say
probably the support, for example, for nearest a date. So we could search for start. I think there is an example also.
Yeah, here.
At the beginning. Yeah. So maybe that's a way to do this nearest thing.
Is Tony here or anybody representing the entity framework folk? No. I mean, you have to ask them about this. But it would be nice, you know, if what you want to know is who was the US president in 1800, right? You don't want to go through some weird thing with implicit entities, I don't think.
Yeah, yes. Then after we have the extended support for entity classes, we can think on a better convenience function that will, let's say, unravel all these entity classes parameters.
Right, but let's think about that right now, because I mean, basically what we want is, okay, so what are the parameters here? There's the type of thing one's looking for. There's the, and then there's the space-time interval, basically.
Yeah, the date interval where that entity
Date.
belongs to.
And, you know, region, georegion, if there is one. Now, the case of a georegion but no date is already covered in GeoIdentify, right?
Yeah, and GeoNearest and all the familiar functions. Sure.
Right. So georegion with a date is also covered in GeoIdentify.
Yeah, that's the extension we want to add. Right.
Although this thing about this president thing is pretty weird. I mean, so we would end up saying GeoIdentify. Now that's just totally weird, because that's what I said here is the type of thing one's looking for. This isn't a type of thing. This is a single entity. I don't understand that one at all.
So why don't we have an entity class of precedents or even an entity domain? So if that was the case, we would put it there. So this feels like we have an entity which is playing the role of a type.
Yeah, that's a discussion for the entity people.
Mm-hmm.
But I agree that that doesn't seem to make sense there. Okay. But so this is, okay, so the goal is, and the goal here is find things of that type.
It's an entity search, actually, with different parameters.
It is, yeah. I mean, the find entity thing is being done by implicit entities elsewhere.
Yep, that's indeed the same somehow. Maybe a difference with some kind of more general entity search is that maybe we will want to search among different entity types, which is what GeoIdentify does, for example. So it may search at the same time between administrative divisions, countries, etc. So that's what entity class doesn't have, because it's always, let's say, tied to a.
Right. So the question is, do we need a find entities function? I mean, to me, event identifier is just not going to make it because they're just not events. But something like a dated identify, it's a weird name. But again, it always returns entities.
Right.
Find entities. I don't think entity classes is going to be enough, because in order to make it powerful, we need to insert operators there. And so we go to the discussion of which operators we would need.
Okay, so if we had dated identify and dated nearest, then the way they would work, we'd say dated identify, and then the simplest case would be an entity type. And what that's doing is it's effectively finding, I mean, it is converting itself into an entity class query. that, and then data to identify would also have a geo possibility. I don't know what happens if the, I see. So that says which of these instances of the entity type exist at which instances of the entity type exist during those dates. And there's then the question of whether there's a within queue and so on and so on and so on. I mean, then the question is, does date within queue end up taking a type, a time, and a geo?
I think if it needs the 3 arguments, then we can do it with geo within queue, even though perhaps it's nicer expressed.
Sorry, that's what I meant. No, wait a minute. Date within queue. Yeah. I see. Geo. You're suggesting that that would be geo within queue, but the problem is.
Yeah, the problem.
I see. If it needs the 3 arguments, you could do it with geo within queue. Yes.
Though it may be nicer this way because it's more important. Time is more important than geo.
Yeah, also in the data identify with 3 arguments. That's somehow what we are now extending in the GeoIdentify. The problem is that probably there are some cases where we don't have a position. So the difference is, for example, for holidays. For holidays, we don't have a position, but we have a geo-reference, which is the country. So that's a different type of entity. So it's not actually a geo entity in the sense that it doesn't have a position, but it has a geographical reference, which is different.
Well, I mean, we could certainly do, if we did something like Geoidentify Country, and we could say all, what will happen if I do that? Okay, so that could mean, if I'm not mistaken, that could mean countries in the whole world. That could be an entity list of countries, and probably should be, right? Because if I say Geoidentify Country, North America, why is this so slow? Why is this so slow?
This is what we are also extending, how to improve all this in the new server.
Well, okay, but this is, what is it doing? What's it doing? What's going on? I mean, this will presumably return a result. What? Come on, what's happening here?
Yeah, I will check, but yeah, the idea is that it should return the list of countries in North America. That's right.
Right, but then this first one here could perfectly well return all of them. And so if GeoIdentify took a 3rd argument that was the time, then in a sense, the only issue is the, oh, for goodness frigging sake. Well, okay, that's a bug. Okay, but then, so then what we're saying is that date identify yeah, I mean, the fact is, in terms of parts of speech, date identify and GeoIdentify are analogous, I claim.
Mm-hmm. Yes. And the case without the geo is important, yes.
I think not only not important is that when you don't have an actual polygon or your position for that entity, like for example holidays might have a country reference but not a position.
Yeah, but you also want, look, just in terms of the semantics of what's going on, date identify of military conflict, 1945. What military conflicts were going on in 1945?
Right, that's a possible way to express that. I agree.
for example, a query could be all the Nobel Prizes of this year, and that's something non-geo.
Sure. And so then data identify would say what things, I mean, and imagine, one could imagine that data identify as well as GeoIdentify could take not an entity type. So that one possibility is entity type here. Oh yeah, look at this, look at this, look at this, look at this. Okay, so let's try this. GeoIdentify, and then let's say, okay, so let's say members of World Meteorological Organization. Okay, so now watch this for coolness, if it worked, which it probably won't. So let's say I say that, and then I say Europe. Is that going to work?
I think the problem is that GeoIdentify is prepared for points in the second argument. So this is probably going to the Geo server and trying to do that for all points of Europe, which is a huge computation.
Okay, so fine. So that's a bug, but semantically, this could make sense. This is
Yes.
saying, so this would allow an entity class here. So for example, for presidents, so long as we have an entity class of presidents, like we might even have right now, an entity class of US presidents. Not a good sign. Well, whatever. So this would make sense. This is a way of doing what you want here, namely GeoIdentify of entity class region will give you those instances that lie within that region. Right? Similarly, date identify of an entity class like presidents, comma, a date 1850 or something, will give you all members of that entity class that lie within that date range. I like this. I think this is going to work. It's got some plumbing to figure out, but I think it's going to work. Make sense?
Yeah, I agree. I think it's going to work.
Okay. All right. Next time. Okay. So let's think about this a little bit more, but then we've got yet more to discuss here. I mean, this people data thing, leaders needs to be discussed too. What is this? Haven't we already addressed this question?
Well, for leader data integration into the Wolfram language, we haven't. We need to define. Well, we have defined right now on alpha that a leader is the intersection of jurisdiction, type of position, and a person. But we don't think that that can be easily converted into the language.
So I'm sorry. Position, time, and jurisdiction. You're saying are the three things that you're intersecting right now. All right. What you just said: position, time, and jurisdiction. Like, vice president of Andorra in 1960. Is that what we mean by that? Did I lose you all? Hello, can you hear me?
I can hear you, and I believe that's what he meant.
Okay. So the issue is something to do with the way that entities are represented and the fact that we can't have that kind of triple in an entity. Because we have the notion of dated, but we don't have a notion of geode.
Right. So the question was if we want this kind of, what will be the best way to represent the entities? We could have this triplet in the entity name, of course, but if there is a better way to expose it.
Well, I would have thought an association, but I don't know whether we do that at all. This is a question. Tony needs to be here for this discussion. This is his kind of thing.
Yeah, I agree. Yeah, that's better to discuss.
Okay, well, we have made progress, so let's try and think through all these things here. But I think we've got a good thing going with this. All right. Great. Okay. Thanks all. See you soon.
Thanks, everyone.
Okay. Bye.
Thanks.
Bye.
Bye.